per VLAN spanning tree plus is a Cisco's version of per VLAN spanning tree, which means there was once an industry standard PVSTP, but later after RSTP, rapid spanning tree, which we are going to see next, the industry standard PVSTP has got vanished, removed. So Cisco took it and modified it as Cisco PVSTP plus. Now, what is special in this PVSTP plus? If you take IEEE 802.1d spanning tree, I would like to call it as classical spanning tree. This is for any number of VLAN in your switch, for any number of VLANs, you will have only one instance of spanning tree, only one copy, only one instant. So if I have 100 VLANs, how many spanning tree? Only one. But this PVSTP, for each VLAN, there will be a separate instant of spanning tree. That is why it is per VLAN. For each VLAN, there's going to be a separate copy of spanning tree, separate instant of spanning tree for each VLAN. What is the advantage? Let me show you the advantage. If I have a topology like this or more switches, I want to keep it as low as possible. I've just taken 4 switches. And now for traffic from left to right, you got 2 paths. One, the upper path via switch B. The other one via the bottom path, below path, switch C. Now, when spanning tree finds a root switch, it uses port number or the priority or the MAC address. Let's assume the priority here is 0. And this will be forwarding port, designated forwarding port. And this will be the root port. And this will be designated forwarding. This will be designated forwarding. And this will be root port. And this will be blocking port, which we learned earlier. Why this is root port? Why not this one? The reason is the MAC address of this is lower than this. Let's say the MAC address of this is BBB. This is CCC. Spanning tree small. It likes small thing, I told you. So small MAC address is this way. So this is preferred to be a root port, and this is a blocking port. Now, there is only one spanning tree running. As a result, all traffic, green, blue, even if you have more VLANs, let's say 100 VLANs, each color is one VLAN. Each color is one VLAN. Let's say this is VLAN VLAN 10, VLAN 30, VLAN 20. Now, all three VLANs traffic is going via this path only. Even though you got another path, that path never used. As long as this path is available, this continues to block. And now, even if there is too rush, this path will never be used. Even though it's too rush, too much of traffic, collision, congestion. Even when it is too congested, switch cannot use this path. The reason is there is a block here. And this block is for all VLAN traffic because you got only one spanning tree. If I have more than one spanning tree, what is the advantage? When I have per VLAN spanning tree, I can say for VLAN 10, priority 0. And for VLAN, sorry, that is VLAN 20. For VLAN 10, priority 0 here. You see, this color is VLAN 10 and this color is VLAN 20. And the blue color is VLAN 20, priority 0. So if this is a root switch, if this is the root switch, this will be forwarding, this will be forwarding, this will be root port for VLAN 20, this will be root port, and one of this port will be blocking, this will be root port, designated port, designated port. So for blue VLAN, for VLAN 20, there's a block here, so the traffic goes like this. Whereas for the orange, this is the root switch. So this will be forwarding, this also will be forwarding, this will be root port, this will be root port, and this will be designated port, this will be root port, and there will be a block here, and this will be designated port. So orange will go this way, blue will go upper way. Upper way, orange is blocked. Below, bottom path, blue is blocked. What do we see here? We are able to use the resource optimally. We are able to use both the paths without wasting our resource. When you don't have multiple instances of spanning tree, this is not possible. Because you got separate instance, you can go and tune one with different priority. Per VLAN spanning tree helps us to do load sharing like this. Per VLAN spanning tree helps us to do load sharing because it has got separate instance of spanning tree. You can go and give different priority to different VLANs and make blocking in different place so that none of the path will be idle. Did you understand this, Andresh?
Yes, sir. I have one doubt.
Mm-hmm.
So the BBB MAC address and CCC MAC address, why is BBB is low than CCC
Alphabetical order, B is coming first and C is coming next.
or something like that? Okay,
Mm,
okay, okay.
okay, and this for our
Like an
understanding,
assumption.
yeah, an assumption, that's all. An
Okay, okay,
assumption, just for us to, I cannot write the big MAC address is 48-bit size, just for assumption.
okay, sir.
Okay, now I'm going to simulate this and do this lab and show you. So we are going to have two more or four more devices, two computers on left and right, two computers, one for VLAN 10, another for VLAN 20. This is also for VLAN 10 and another one for VLAN 20. And I'm going to connect the cable to the switch. We need to go to these four switches and configure, create VLAN 10 and 20. I'm going to configure VLAN 10 and 20 on these four switches. Okay, that's the first step I'm going to do. And then I'll go and assign this computer to VLAN 10 and this computer to VLAN 20. Likewise here VLAN 10 and VLAN 20. And for VLAN 10 computer, I would like to give IP address 10.0.0.1 to here. And this one 20 and this one like this. Okay, this is the LAN. Now let me go and configure IP address first. That's for your reference. I have written there. This is how you configure IP address on the simulated environment 10.0.0.1 and mask is this. Gateway is not needed. To verify, you can go to this command prompt and type IP config. You can see the IP address is given. And likewise for this computer, and the IP address I want to verify. Yeah, 20.0.0.1. Likewise on this computer, 10.0.0.2. And here, IP config. Oh, la la. Okay, 20.0.0.2. What did I give you? 10.0.0.2. Here I need to give 20.0.0.2. IP config. Okay, now we don't have VLANs. Let's go and create VLANs. First on switch 4, which is on the left. For you to easily verify the topology, I have arranged like this. These are the commands. Host name I give switch 4. That's how we name the switch. And then the VLANs I want to create is VLAN 10 and VLAN 20. Next is I need to assign this F03 to VLAN 10. For that, go inside interface F03 and then say switch port access VLAN 10. I told you in the previous class, these ports are called as access ports. So you need to mention it by typing this command switch port mode access, meaning you are not a trunk, you are an access. Next, interface F0/4, switch port mode access, switch port access VLAN 20. Let us verify. The verification command is like this: show VLAN brief. You can see that this two interface is now given to different broadcast domain. You see on the top, after 01, 02, 03 and 04 is missing. Why? Because it's moved to the other VLAN. Next is, I want to make that F01 and F02 as a trunk port. These two port is connecting to another switch. We need a link between the switches which can carry multiple VLAN traffic. To carry multiple VLAN traffic, we need to configure those ports that connects to the other switch as trunk port. Now, what are the ports? Interface, range. Why I use the range command? Because both the interface, I'm going to put the same command. Instead of going individually to each port, instead of going individually to each port to put the same command, you can use the range command and get into all the ports at the same time. Like this, interface range F0/1-2, switch port mode access, switch port mode trunk. That's it, switch port mode trunk. Now let us verify. Exit, show VLAN brief. You can see that 1 and 2 is missing now. Where it has gone? It's nowhere here. Why? It is not a member of a single VLAN. It's a member of all VLAN. So it should not be listed here. It is here. Show interface trunk. You can see here. Interface F01 and 2 are allowing all these VLAN because it's a trunk port. Because it's trunk, it's trunking. Because it's trunking. Okay. Similarly, I'm going to configure switch 3, and then we will come to switch 1 and 2. Switch 3. Switch underscore 3, and then I say interface. No, let's create VLANs. VLAN 10, VLAN 20. I told you the name of a VLAN is optional. That's why I don't give name. Next, interface F0/3, switch port mode access, switch port access VLAN 10. And then interface F0/4, switch port mode access, switch port access VLAN 20. Tell me what I should configure. F01 and 2. Switch 3 is F01 and F02. What should I configure? Should I configure access or trunk? Switch 3. Switch 3 is F01 and 2. Switch 3 is F01 and 2 connects to another switch. It needs to be trunk, isn't it? Yeah. Interface range F0/1.
Trunk. Yes, sir, trunk.
So F0/1-2. Switch port mode trunk. That's it. Now I have to configure this switch with VLANs. Switch underscore 1 and VLAN 10, VLAN 20. Do we have any interface member as VLAN 10 and 20 in the switch? No, we don't have any computers. Then why should I configure VLAN 10 and 20? Listen, this VLAN 10 in switch 4, we need to extend it. Even though there is no member in switch 1 and switch 2, even though there is no computers connected, we need to create those two VLANs. Only then the VLAN 10 can get extended up to the right-hand side switch. The middle switches need to be part of those VLANs, even though there is no member connected to them. Did you understand? Okay. To make sure you really understand, I want to put it in Tamil.
Yes, sir.
இங்க VLAN 10 இருக்கு, இங்க VLAN 20 இருக்கு. இங்க நமக்கு VLAN 10 வேணும், இங்க VLAN 20 வேணும்னா நடுவுல இருக்கிற switch அந்த VLAN 10 மெம்பரா இருந்தா தான் எக்ஸ்டெண்ட் ஆகும். VLAN 20 மெம்பரா இருந்தா தான் எக்ஸ்டெண்ட் ஆகும். ஸோ எல்லா VLANம் எல்லா இடத்துலையும் இருக்கணும். மெம்பரே இல்லைன்னா கூட VLAN 10க்கும் 20க்கும் மெம்பரே இல்லைன்னா கூட அந்த VLANs நம்ம கிரியேட் பண்ணி தான் ஆகணும். அப்பதான் இங்க இருக்கிற VLAN டிராஃபிக்கை இது வாங்கும். VLAN 10 டிராஃபிக் வரும்போது இது வாங்கணும்னா இது VLAN 10னா என்னன்னு தெரியணும். அதுக்கு VLAN 20 டிராஃபிக் வருதுன்னா இது உள்ள வாங்கணும்னா இது VLAN 20னா என்னன்னு தெரியணும். தெரிஞ்சாதான் வாங்கும். So we need to make known to the switch about those two VLANs. That's why I go under switch 1 now and I put VLAN 10 and 20. Next is those two interfaces need to be a trunk port. So interface range F0/1-2 switch port mode trunk. Boom. Likewise on switch 2. Is this topic new to you, or are you learning these things for the first time? Okay, then you should be feeling interesting. You'll really like it.
Yes, sir.
Hopefully.
haven't
Do you
learned
like
this
these
before.
topics? This is networking. You want to protect your network. If we don't know the network, how
Yes,
can
sir.
we protect, isn't it? So it's good that you are here. Interface range F0/1-2 switch port
Yeah.
mode trunk. Okay, now don't worry about the commands. As the day go by, we'll be learning commands. I'll teach you this command line in another class. Here we are learning spanning tree protocol. Focus only on that. And now, if you go and see the blocking port, the blocking port is here. There's a red I can see. Anyway, that's not our aim. I'm going to make this as a root switch for VLAN 10 and this as a root switch for VLAN 20. So that VLAN 10 will go via the upper path, VLAN 20 will go via the below path. How do we do that? I'm going to configure a port, switch priority. For VLAN 10, I'm going to give priority 0. Smaller the priority, high weightage is given. For VLAN 20, I'm going to leave priority default. Priority default, which is 32768. I don't change. And here, opposite. VLAN 20, priority 0. VLAN 10, priority 32768. Okay. You understand, right? What we are.
Yes,
Okay. Now let us do that first. I will go to the switch 1.
yes, sir.
Switch 1. And this is the command. First of all, we need to configure per VLAN spanning tree. How do we do that? Spanning tree mode per VLAN spanning tree. Enter. So I need to put this command on all switches, so I have to do it on other switches as well. I'll go to switch 2 now. Spanning tree mode, power VLAN, spanning tree. Next, switch 3. Spanning tree VLAN, power VLAN. Sorry, spanning tree mode, power VLAN. Next. Spanning tree mode, power VLAN. Okay, on all the switches we have enabled power VLAN spanning tree. What next is, as per the plan, we are going to set the priorities. I'll go to switch 1 first. In switch 1, this is the command. Spanning tree for VLAN 10, priority 0. For VLAN 20, I will not configure. Why? That's default. 32768 is default. Okay, next. On switch 2, for VLAN 20, I have to do that. Spanning tree mode, spanning tree for VLAN 20, priority 0. That's it, that's all. Now you will see VLAN 10 will be sent via the upper path and VLAN 20 will be sent via the below path. In short, what I want to say is both the paths are going to be in use. Let's see. All right, I'll go to switch 4 and see the spanning tree status. Show spanning tree. If you notice, here, for VLAN 10, the interface 1 and 2, it's forwarding. And for VLAN 20, it is forwarding. This is for VLAN 20. You see the priority is same, 32768. Okay, this is forwarding for both. Next, let's go here and check. Show spanning tree for VLAN 10 first. Here also it is forwarding for VLAN 10, but what about VLAN 20? VLAN 20 also it is forwarding. Now then, who is blocking? Let's go and check this one. Show spanning tree for VLAN 10. Okay, listen. For VLAN 10, you see the priority is 0. It's forwarding. Whereas for VLAN 20, it is blocking. The same switch for VLAN 20, for VLAN, for VLAN 20, it is blocking. Whereas for VLAN 10, because the priority is 0, it is forwarding. Likewise, on the other switch, if you see, show spanning tree for VLAN 10, it will be blocking. You see, for 10, it is blocking because for 10, we did not change the priority. For 10, it's blocking. Whereas for 20, it is forwarding for both, forwarding on both the ports. Because for VLAN 20, we have changed the priority to 0. This is switch 2. So we can see that Both the paths are in use. You see, I'm going to ping from here. I'm going to ping from here. Ping -t 10.0.0.2. See, it's going to be keep on pinging. Actually, it's going via the upper path. And I'll go to another computer here, this one, the second computer. All right, I'm going to the second computer. And I'm saying ping without stopping. That's what timelessly. -t means timelessly, without stopping. Ping 20002. It's pinging. So now both are pinging. Both are pinging. 10.2 is pinging. 20.2 is pinging. Now, if I cut this wire, tell me which one will get disturbed. If I cut this wire, which one will get disturbed? No. If I cut this wire, which ping will stop? VLAN 10 or VLAN 20? Which ping will stop?
Says which one?
Oh, come on, what happened? You see, the upper path, VLAN 10 is going.
VLAN 20.
If I cut this wire, VLAN 10 will go down and it will switch to this path. So it will take some time. That's what I'm asking.
So
If I
VLAN
cut this
10.
wire, which traffic will get disturbed? VLAN 10 will get disturbed. Yeah. So what I'm trying to show you here now is, I'll cut this wire. You will see VLAN 20 will be pinging without ceasing,
VLAN.
but VLAN 10 will cease for a while. Shall we check that? You understand what we are trying to see? Okay. So I'm going to cut the wire, and you will see that only VLAN 10 get disturbed, not
Yes,
VLAN
sir.
20. Cut. How to cut the wire? Now you see. VLAN 10, I lost. You see, request timed out. Whereas VLAN 20 is still pinging. VLAN 20 is still pinging. But VLAN 10, you see, request timed out. For a while, it will be request timed out. Why? It has to switch from this path to this path now. VLAN 10, it will switch. Give some time. It will switch. VLAN 10 without any problem. VLAN 20 without any problem, it's pinging because that path is not damaged. VLAN 10 path got disturbed. Now it has to switch to the below path. We are waiting for the switching to happen. Yes, you see, it started pinging now. You see that? But this delay is not acceptable. That's why we are going to learn rapid spanning tree in our next class. Now, let me put this wire back.
Yes, sir. Yeah.
When I put the wire back, again, there will be slight downtime for VLAN 10 because it needs to switch back to the original path. You see, again, there's going to be a drop. You see, dropping again because it needs to switch back to the original path. You understand? No, that is expected. In a network, acceptable delay is 300 milliseconds,
Yes, sir.
but
But this time
it
frame
is
should be
not.
within
That is
300
why we are going
milliseconds.
to learn another spanning tree. I'm explaining the drawback of this spanning tree which we learned today and yesterday. The difference between yesterday's spanning tree and this spanning tree is yesterday's
Rapid
spanning tree
spanning
is
tree.
single instant for all VLANs.
Okay, sir.
Today's spanning tree is per VLAN. You understood that point? Okay. Now you see for VLAN 10 it is pinging. Now if I cut this wire, the below wire, which will be getting disturbed, VLAN 10 or VLAN 20?
Yes,
No,
sir.
the below
Yeah.
path. Because priority is lower here for VLAN 20.
VLAN 10. VLAN 10.
This is the route. Okay. So now I'm going to cut the
VLAN
wire
20, sir.
again,
VLAN 20.
but this time it's going to be for VLAN 10. Now go and check. 10.0.0.1 without any problem, it's still pinging. But 20, it is gone. 20 VLAN is gone. But 10 VLAN is still going on. No problem. 10 again, it will take some time. It will lose at least 5 packets to switch. I told you yesterday, it will take at least 50 seconds. 20 seconds of timeout, 15 seconds of listening, and 15 seconds of learning. Totally 50 seconds. That's what you are seeing now.
Yes, sir.
Now it's pinging. Now, when I connect the wire back, again, there will be a drop because it has to fall back to the original path. Okay, now I would like to show you one more time clearly. Please focus one more time. For VLAN 10, I'm going to cut the wire. Okay, before cutting, on switch 2, I would like to show you before cutting the wire on the upper path, I want to show you on the switch 2. Show spanning tree for VLAN 10. You see, there is a block here, right? In switch 2, there's a block here. But when I cut this wire, this block should turn into forwarding, isn't it? Let's see.
Yes, sir.
I will cut this
Yes,
wire.
sir. It should.
Okay, after cutting, I'm taking you back to the same switch. Earlier, it was blocking, but now it's still blocking. 20-second timeout value. So after 20 seconds only, it will go to listening state. See, it's in listening state, LSN now. Meanwhile, if you go to the computer, you'll see there's a drop in the packet, and this is still in listening. Now, still it is in listening. It's going to switch to learning now. 15 seconds. Okay, you see LRN learning. So still the packet is in drop. Once this turn to forwarding, only then the ping will be successful. Still it's in learning, 15 seconds of learning. So now it's forwarding. Now go and check, the ping would have begun. Look at this. You understood? All right, this is how the convergence, but it's a slow convergence. It is automatic. Spanning tree does this automatically to prevent loop, but it's slow in convergence.
Yes, sir. Okay. Yes, sir.
That's why we are going to learn another flavor called RSTP, Rapid Spanning Tree Protocol, in our next class. Any question on what we have seen today and what we have learned today? Right. I want
No, sir. No.